So these are two different reactions. In the slow reaction right here, what we're basically saying is, let's say that I've got a little kid who, or maybe a teenager who's like on the track team and they can run really, really fast. But he's with his grandma who has a walker, or grandpa who has a walker, and they're trying to get across the road. Yeah, that guy could run across the street, no big deal. But what limits them both getting across is Granny with a walker. So we have two steps. We have a fast path and then we have a slow path. So the entire reaction is governed by the slow path. Everything else happens really fast afterwards. So what we can say, if we know the mechanism steps, and this is all key to it. These are, so we kind of make guesses. I sometimes say it's like beam me up, Scotty. So we're making guesses about how the reaction ends up at the end because we're not actually literally seeing it happen. We have a lot of support for why some mechanisms are what they are, but these are kind of guesses. And what should happen is that for the slow step, its reactance rate law just based on exactly what's showing there. So I've got H2O2 and then I've got an I minus. That should match with what you actually find out experimentally. So you can't do it with any of these. You cannot just jump to it and use the coefficients like you can for the K, the equilibrium. You can't do it that way for these unless you know all the mechanism steps and you are making a big assumption you know which one is the slow step. What this is literally saying is that for the reaction to happen, an I minus has to bump into an H2O2 exactly correctly. And that's what takes the longest to happen. Once that's happened, then apparently it's very easy to have the next step occur. All right, so then on this next one, determine the rate law, the overall reaction. Oh, and I didn't mention all the rest of it. Sorry, on this one. Let me go back. So remember, catalyst is something that is on there initially and at the end. It's kind of like a reaction helper, and you don't use it up, which is great because a lot of catalysts are very expensive or they have high value in the body, and thus it's complicated for the body to make catalysts. In contrast, intermediates are things that you never started the reaction with and you never end it. So you never collect an intermediate. It doesn't exist for necessarily very long at all, but it's what is made and then used up. So yes, they're both things on opposite sides, but they're different kinds of opposite sides. So the overall reaction, you cancel the stuff that's on both sides and you can add things that are on the same side. So when I put these together, these two are going to add. So I get 2H2O2 goes to, and then notice I've got two waters, 2H2O plus O2. Notice I am not basing my rate law on the overall reaction step, but that is the overall reaction. Okay, now I'm ready to go to the next one. Then this is my proposed slow step. So I go to my reactant, and my rate law is very simple on this one. C4H9Br. That's my slow step. Now, for my two fast steps, they don't go into the rate law at all. Again, this is my limiting step for my speed, but they are going to influence if we have any catalysts or intermediates. Just try and bring the words in here. So for this one, again, I'll use the same color coding on it. So for the catalyst, you're going to have to start with it. Well, notice that this is the only thing I started with. I don't have a match for it on the other side. So there is no catalyst on this one. But I probably have a lot of options. When you have all these layers, then you tend to have a lot of options. So this one is not, because I'm not seeing BR on the other side. What I do is I look at the right-hand side and I just try to find a match on the left. So that one doesn't have a match, but this one does. I'm going to go back over here. Does this one have a match? Yep, it has a match also. So those are my two catalysts. I'm sorry, I said the wrong word. Those are my two intermediates, C4H9 plus and C4H9OH2. I know that looks crazy. You'll understand that more plus when you get to organic chemistry.